Hello and welcome to my virtual session for the Data Innovation Summit, which is focusing on building a data foundation to enable machine learning, AI, and data analytics. And this is, really focusing on data management and also the importance that it's facing towards, the machine learning, AI, and modern data analytics capabilities. So, hope you enjoy it. First of all, just a little bit about SEB. So I work for SEB, focusing on data architecture and data management. And SEB, as for those who don't know it, they're one of the leading Nordic banks, and we're based here in Stockholm, Sweden, with offices across the world. So here's a snapshot of what we do and how well we do it. And moving along, so in SEB, we're like a lot of banks, we really are data driven, and we're focusing heavily on building up our data management capabilities to really leverage on the AI, machine learning, and the data analytics possibilities that are, which are increasingly out there. So these are some of the sort of the data management foundation areas that we are building upon that are needed for these areas. So just to give a bit of background, for why these are so important, focusing on the challenges that us banks are facing regarding some of the obstacles and some of the challenges that are making us difficult for these type of areas. And then, leading on to then why is it so important to improve these data management capabilities, and then and how they're formed to create data to enable your capabilities to leverage the AI and the machine learning and so much of the data analytics capabilities that are needed for these areas, and then explaining how these actually take place via knowledge graphs and semantics, which essentially the underpinning so much of the modern data analytics areas that are needed for those, which are deployed today by Google, Facebook, LinkedIn, all these areas that already have these in place. So challenges for banks. So essentially, why this is so important, and for why a lot of the capabilities that are so important for us now has really shifted from where they have been in the past, is because of the explosion of the data volume and the complexity that we're facing today. And if you look back, 10 years ago, at least on the screen here, that the data sizes and the sources where the data come from are nowhere near the size that they are from today. Today we have data coming from different sources, from not just warehousing, but different devices, different smartphones, different smart devices, embedded systems for the giving out data. So and most of this data is unstructured, and 90% of this data that we are retrieving today, or is available to be consumed, is unstructured. So you can see that just how much of the different types of data and the types of the data and where it's coming from is just growing at such a magnitude of an explosion that it's the old way of capturing data, managing data, and analyzing data just doesn't fit the forward-looking approach. So this is where we will shift towards semantic data, knowledge graphs, and the type of approaches I'm talking about today are so important if you really are going to leverage on the benefits of AI, the machine learning, and modern data analytics. And if you look at and how what does this mean in terms of how has data changed, from back in the days where we have, especially for banks, a lot of legacy of data warehousing, silo data warehouses sitting in different parts of the banks, which are very much based upon relational databases. These types of structures of data don't fit today's world in terms of the magnitude and disparity of data, which have lent themselves to be more dispersed and more distributed by the semantic web type of languages of just here the RDF, the RDFS, and the OWL, which basically come together for knowledge graphs. And that's what, again, the Googles, the LinkedIns, Facebooks, they all use that distributed data via knowledge graphs. And that's where for us in the SEB and a lot of the banks, particularly too, are focusing on this type of techniques to really go from the human understandable presentation of data to moving towards distributing your data for a machine understandable presentation or representation of that data, which is needed for your models, your algorithms, your AI, and so forth. So essentially, it's going from strings, which is which we find defined in your databases, your columns and rows, to things, which is your distributed concepts of data which come together for relationships and patterns, which gives you insights and models and automation and the machine learning algorithms that take place. And this is what I'll be talking and focusing very much on today. So to get there, there's no silver bullet. There's no quick fix of like, let's just shift, the boat around to go from, human readable to machine readable. It's not as simple as that, especially for us banks where we have a lot of legacy, we have a lot of warehousing data that needs to be moved from the old way to the new structure of distributing your data. So essentially, it's like the staircase of capabilities that we're focusing on, and a lot of banks have gone through this route, have all gone through the similar approach of, you have this data siloed across the different parts of the organization, and they have their own labeling and own meaningful insights of their data in their warehouse for that part of the bank or their organization. And the first step is to really organize that data more effectively and more efficiently to just getting like a common data management approach, common structures, which is, that staircase of trying to get to that common data element of, compiling all your data across the organization, having common data descriptions, common metadata, common data management, common data structures that then allow you to actually understand the data and to provide meaning on that data, which is then on the next step, the semantic data. Semantics, basically is looking at the meaning of the data. And that's the real focus of, if you're going to do any analytics or any machine learning or AI, you need to understand the meaning of that data and what you actually have. And that means, looking at the different types of sources, what the things are similar, different, and then to put them together through, common data management areas. So you actually get reliable, high quality data for those models that you're going to be building upon. And then you reach, so that staircase of where you're trying to get to, that the AI, automation, machine learning, it needs the data to be structured and performed in a particular way to really get those decisions and insights that you need. So, and this is so important because the complexity of data that banks are facing is so great and getting greater and greater, particularly when we're facing towards a cloud where we can consume so much different data through cheap storage and compute it so quickly. But to do that, you basically need to have share that data and to organize it like by a catalog or a hierarchy to really get the benefit from the capabilities that are now available through the cloud and to analytics, and that's basically through these knowledge graphs and graph technology. And it's not just the graph technology that is really driving this. You look at what are the different types of AI tools that drive upon these capabilities. What are some of the personal channels that the robotics and the virtual VR and the and also the chatbots and also behavioral AI and like NLP, for example. These all require certain types of models and data to be automated and to be structured for the machine to read what the data is actually telling you and what are the patterns. So you can't just feed data through unstructured ways and hope that it'll do it by itself. It doesn't work like that, and that's hence the importance of data management and data capabilities to get your data ready for the machine learning and AI capabilities that are so far coming at us so quickly, and all need these common capabilities in a particular way. So the real sort of shift, of rather than looking at more data, it's really focusing on the right data, and that's that's what we're doing in SEB. Is that yes, we all know that the data is a key strategic asset, but for our new business models coming out of the AI, machine learning, and data science driving the new analytic insights, it's really focusing on the right data and in the right way to get that business value, and that's the focus of why these data management capabilities that I'm talking about today are so important to get that right. So, how do you improve data management capabilities and to get your strong and really meaningful models for AI and machine learning? Well, essentially, you need to understand that data and information aren't the same thing, and that's the thing, that you start with data, which are like just data points, and data by itself doesn't give you anything. There's no meaning with it. But once you apply meaning to data, then you have information, and then you can actually start providing analysis on information which gives you knowledge, and that's where you have different contexts to apply to knowledge. Hence, like the knowledge graph that, say, for example, like Google and the Facebooks that use. That once you get to that state, then you can start understanding that knowledge to provide insights. You can provide predictive, prescriptive analytics, and then you can start bundling that data together via models through decision reasonings, algorithms, then and the AI. So the AI machine learning, they all start on the right-hand side, but as you can see, you need to do a lot of work on the left-hand side to get that raw data or unstructured data moving from information to knowledge to insights to get to where you need to be. And that's it's really important to understand that you need to get strong data management capabilities to actually move that data into the right format to get to where you need to be. So essentially, you think of data by itself as just data points, and you look at like this page, data is like just dots. It doesn't mean anything by itself, and looking at it, there's no meaning there. But once you start applying context to data and looking at relationships between data, and looking at the interaction of different data sources or different data patterns, and looking at what data concepts actually mean, hence the meaning of the data, then you can start applying meaningful business rules, looking at models for the AI and machine learning, and then you start getting the business value and insight. So it's really these areas are sort of fundamental to get to insights and the semantics right before you start getting the business value. You can't just look at it from data points. And to do that, you need to do basically data curation, and that's what we're focusing on in SEB, is looking at the different types of data management capabilities to curate our data from the data points to basically the foundation that can be used for your machine learning and your AI and your data science algorithms and models. And essentially, to transform the data to knowledge, it's following as a very simplistic data value stream. So you create the data by your common data structures. So you're grabbing similar common data structures, your common language. Then you can create it via your core data management of metadata management, business glossaries, your data catalogs. So you're organizing your data and structuring your data in a very consistent, common way, which is just critical to start graphing your data or expressing your data in a knowledge graph like here, which is your smart data. A knowledge graph basically is it's a machine readable way of looking at your data, but also it's focusing on the meaning of the data via concepts and the relationships to understand what you actually need for your models that are going to be consumed. And that's critical to understand and go from that that common structure, managed data, and then to the smart data. And what does that actually mean? Well, again, the components that really sort of take form for these is that, first of all, for your common data management capabilities, it's starting with your conceptual data model. That's essentially your business-facing view of your data. And you could sort of describe your conceptual data model. It's like the map of the world of your data. So you're dividing your data into your common domains, so that you can then apply a common language, a common labels on your data, and you can apply context on your data, and then slice those domains into where the data relates to hierarchies, which is basically fitting into how you classify your data and how you catalog. And again, when a lot of us are moving to the cloud, the data catalog and how you structure your data catalog is critical if you're going to get your data analytics capabilities leveraging for your AI machine learning, because again, you can consume and ingest a huge amount of data, which Google and Amazon and Microsoft allow you to do, but you need to structure that data. You need to catalog it so that it's like for like, and actually the hierarchies of consistent structured data are applied via a taxonomy type of rule. And that is needed for you to look at the different relationships that a data graph or an ontology, which is basically what a data graph pulls upon, is that you're structuring those rules and relationships via the patterns that can be repeated by the machines or the AI in a very consistent, logical way. So that's basically like a high-level summary of the data management to get from to the graph. And for those who haven't seen a conceptual data model, here's an example of a banking conceptual data model. Again, so slicing the data into the common domains across the organization. So look at this one. On the top you have the data relates to products. So you have products basically building blocks of financial instrument data, and then which are derivatives, which are then given value via market data and reference data, and measured via risk, which is at the right hand side. And then on the left hand side, you have the financial data, which is basically your accounting, your balance sheet, your P&L, and then the bottom half of the conception model is basically your customer-facing data, so your channels of how we interact with their customers, the organization within an organization, of how we structure the data. And that allows you to have context on here, and then for each of those domains to label their data and to reference that data across the organization for what is relevant to their domain. So that's really important to get right, or to have in place, to really have a meaningful value-adding business glossary, because a business glossary can mean different things for different parts of the organization. So you first need to look at your holistic overview, look at the map of the world. And so when you describe a glossary, let's take, for example, the word or the concept account. For a bank, account can mean many different things in the organization. So for the conceptual data model, you look at it and say, well, if I'm describing it and I sit in finance, an account for me relates to the balance sheet. So for a business glossary, you describe in that context an account relates to a balance sheet and has a certain set of rules that it needs to follow for reporting on a balance sheet or accounting rules. But if you're sitting in the product side of the bank, an account is, like, for example, a type of current account or deposit account, and that will have a completely different definition of what an account means, and actually what are the rules that relate to a product that relates to a current account. So you really need to get that context right before you start defining a business glossary and a catalog and business rules, so that you can communicate and distribute that data across your common organization in a common way and common structure, but you can reference the context of which you're describing the data from in that domain. And that's really important, because when you start describing your graph, you're pulling upon the different contexts and related concepts to that item, also to that data area, so you can look at that full graph. And to bring this into example, this is where metadata and lineage is so important. So we all love Tableau dashboards or dashboards in a different tool and analytics. To actually trust that data, you need to understand where the data has come from. And that's where metadata is so important, because you need to understand where the data is sourced from the ingestion, and then how is the data transformed by the various business rules or applications to get to that dashboard. And that's essentially why data management is so important, because you need to trust the data and understand that data, because if you don't understand how the data has been transformed or changed from ingestion to consumption, then you can't trust that data, and you don't know how reliable that is to give you those insights or the models that the machine learning is going to drive upon from the building blocks. So you need to really have a strong metadata management capability to understand who is changing the data, who is owning the data, how are they referencing the data, how are they communicating that across that data, from the middle, from the start to the end. And that's really important, and essentially why lineage is so important, to understand that sort of the pathway from ingestion to consumption. And that, speaking of consumption, that's where you get the knowledge graphs and semantics, which is again so important for distributing large complex data sets across a common platform that you can then start building your machine learning and AI models, and particularly do common data analytics that draws upon this common data set. So, and this is sort of expressed here in this diagram here, that you think about it, in organizations and us in banks, we're consuming and ingesting so much different data sources and different formats and unstructured data sources that need to be, first of all, linked and harmonized, so that similar data sets or the same things are then mapped and managed to data management capabilities via a catalog or common formats and common structures and common consistent ways, but then used to validate that before the model can, before the machine can read it, is it consistent? Is there no irregularities? Are there any data quality rules that haven't been applied correctly? And once you have that validation and data quality and the semantic rules in place, then you can start running your models and your machine learning and your automation to really infer data, to classify it, and to enrich it for your machine learning to do its job. And that's where you get scalability. You can automate, and then most importantly, you get business value once you have all these things hooked up. And that's where it all starts from, your data management. Once you ingest it, and then applying your various semantic and business rules and data quality rules to get that, the strong business value from your machine learning and AI. And for those who haven't seen a graph or want to know how a graph looks like, this is a knowledge graph that relates to one of our trading desks. This relates to here. This is a fictitious FX trading model for a knowledge graph. So you can see in the middle, that's okay. What are the components or the concepts that relate to an FX trade? And you can see on the right-hand side, for example, everything that relates to a customer. So a trade for a customer has a life cycle. It needs to have an identifier. It needs to have an amount, an exchange rate, a status, a date, and so on. And the left-hand side, for an FX instrument, it needs to have a deal type. It needs to have a transaction event. It needs to have an exchange rate. It needs to have a channel, which is what we call a media. And then that trade is then bought by or sold to a customer, and and also another part of a party is a trader. So you can see all the different components are then expressed, rather than looking at tables and rows, it's expressed as a holistic overview or a holistic graph of what are the most meaningful concepts that a data point needs to include for your machine learning or AI model that's going to be consumed, or your data analytics, particularly with BI. And this is where this context here is so important for us to get right, that if you're going to do BI, you need to have all the right concepts expressed in the right pattern and relationship to get the right dashboard or the right analytics out of it. And here, as a more sort of concrete and more simplistic knowledge graphs, to emphasize how important context is. If, for example, that you want to know from your model, I want to know all the customers that have consumed or we've sold FX trades to in the last year. Well, first of all, then you need to understand, well, what type of customers do you actually want to know? The machine would ask you, or your end user would know. And then you need to map in, or in banks, you have individual customers and you have organizations. So, and each of those have identifiers. So, in the individual, they have your personal number here in Sweden, and an organization will have an LEI. So, you really need to start separating these concepts out, because each of them have concepts that you pull into that give you information that the machine will need to provide the analytics that you're trying to pull upon, that data that you're aggregating. And then, speaking of aggregation, particularly, which is the big part of us in banks, if you want to look at, for example, I want to look at the total amount of swaps we've made money on or lost money on over a certain period, you need to decompose that in terms of, okay, what are the different types of swaps that you actually trade in an organization? And that's where the graph here becomes so important, because you can use ontologies like FIBO, which is a common industry ontology of financial instruments, to help you guide in terms of, okay, what are the different types of swaps that are out there in the financial industry, and then what are the rules and meaning of that data for the different types. So, for example, here for interest rate swaps, you have different types. You have a single currency, you have cross currency, you have fixed, floating. So this helps you looking at, if you want to aggregate that data, what type of concepts of different types of swaps do you actually want to select here for your model, for your analytics or your machine learning or AI, rather than saying, I want to aggregate swaps, because the machine doesn't know whatever you include in terms of the different types of swaps. You need to map these out in your patterns and distribute that data via those structured rules and patterns and business rules to get the right aggregation and analytics if you're going to predict or prescript via your analytic patterns. So the graph really, first of all, shows you what you need to, what you have, and if they're being mapped correctly via the patterns and the rules, to ensure that you get the right end value in your analytics or your machine model. And then if you want to automate that, the machine reads these patterns and rules that you actually mapped. So hence the graph is really a cornerstone for your models. So that was a really quick overview of how important data management is, and particularly knowledge graphs and graph technology is to enable machine learning, AI, so and modern data analytics. So I hope that found that really helpful to you. If there's any questions, so if you want to learn more, you can email me here at SEB with my email address, or feel free to reach out to me on LinkedIn under my name, and I'm happy to answer any questions and find out more information for you. if you need. So good luck and thank you very much.